a lesson. And they keep writing this on the PowerPoint, and they're saying the null is that the mu of the difference equals hypothesized value. That's silly because it's always going to be 0 for the content of our course. We're testing to see if the difference is 0. Now, this is theoretical. You could test that the difference was some other number, but you would never get that on the AP test. On the AP test, this is always going to be not hypothesized value. It's always going to be that box, that the difference equals 0. That's why if we do a confidence interval, we're looking for 0 in the interval. And if 0's in there, we would F2R. We would fail to reject the null because 0's in there. And if the confidence interval goes from positive to positive or negative to negative, we would reject the null because we're looking for 0. And if the confidence interval went from, I don't know, 5 to 8, we would reject it because 0's not in there. If it went negative 11 to negative 1, we would reject it. So here are the conditions. And this is so redundant that it's on all these slides, but that's helpful, okay? SRS, or random assignment of treatment. The sampling's got to be less than 10% of the population, and the difference is when you do list 1, take away list 2, you have to have 30 or more. If not, you have to have information that the two populations are approximately normal. If you have neither one, you use your calculator to draw a box plot of the differences. Now, if that's confusing to you, that's in the document from the late opening. It's in Canvas. I posted that problem we did. Was it Tuesday was late opening? So you people were here. And we did that problem in class, and I posted the solution. And that's one of the problems where in the conditions, there's a box plot. Degrees of freedom, 1 less than the number of differences. So we got this scenario, and it says you're going to experiment to study the effect of caffeine withdrawal. So you got 11 volunteers, okay? During one 2-day period, subjects took capsules, their normal caffeine intake. Another 2-day period, they took placebo capsules, and the order was randomized. At the end of each 2-day period, a test for depression was given. And the researchers wanted to know if being deprived of caffeine, not depraved, would lead to an increase in depression. Okay? So here's everybody. 1 through 11, except we don't know what order these bottom two rows came in. 1 was the depression score when they got the pill, and 1 was the depression score when they got the placebo. So what's the null? The null is that there's 0 difference between the two scores, whether you got the placebo or you got the caffeine. You gotta be careful. It's a one-tail test. It's a one-tail test because you're testing to see if the depression score goes up when you get caffeine as opposed to getting the placebo. Or I'm sorry, the other way around, right? If your depression would go up because you don't have the caffeine, right? So we want to see the difference is positive. It's a positive difference between placebo subtract caffeine. which is the same thing as if you said negative difference if you went caffeine, take away placebo. Because they're saying, would people get depressed if you took away their caffeine? When people say, there's a lot of people that don't, like Mormons don't take caffeine. It's like a religious thing, okay? And like I drink coffee, and people think, oh, it's no big deal. But coffee has effect on your body, this caffeine, and you have to be aware of it. So here's the scenario. Are we good? And because no significance level is given, we'll go to default, which is alpha's 5%. Except what? It's a one-tail test, which means don't do a confidence interval, because confidence intervals are always two tails. It means do stat test 2 for this data. Now, we're not going to load this in the calculator. You're just going to watch it. Do not do a confidence interval for a one-tail test. So what happened? Well, the sample size is 11. So we're going to have to plot the differences. And, they did the histogram. We would do a box plot. Okay. Random assignment of treatments. So here's what they got. They got a T-score of over 3. Hello? When we draw the curve, we only go 3 steps right and left. If you're past 3, that's going to tell you to do what? To the null. You fail to reject when you're close to the null. You reject the null when you're out in the tail. This is out in the tail. You're going to reject the null. Okay? Now, we're going to have to quantify that and see what the p-value is. But if the t-score is that far out, ready, it means this. If we have this picture, think about this. Here's a picture. There's a z-score of 0. That's where the null is. So if you're here, 3.5, because it's a one-tail test, we're rejecting it because the null's over here. We're far from the null. The time that we fail to reject it is if we're closer to it. Now, that's just like in general. We have to quantify this, but you need to conceptualize this and say, I see how this comes together. Because every year, there are children that do it backwards. It's fine. It happens every year. And then hopefully, through the assessments in here, they get this thing straightened out in their mind. But I can't tell. I can tell by the AP scores who fails it up in May. Because those people bluffed. Oh, I get it. And then they apparently didn't. So what did they get as a p-value? 0.0027. 0.003. Okay? You're in the tail. Reject the null. We have evidence that caffeine withdrawal increases depression. I'm not worried about this. But this is helpful. Read the question. And this is asking you, is this a 10-2 problem where you do a 2-sample t-test? Or is this a 10-3 scenario where you do a 1-sample test of differences? I'm not going to read it. You can see it from here. I hope, right? I'll go back there. If I can see it from back there, you can. Yeah, that's fine. So is that blocked or not blocked? If it's blocked, it's either repeated measure or matched pair. Who thinks what? about somebody at home? How about somebody sending a chat about whether they think that's blocked or not? Did everybody walk away from their screen? Zero chats? Really? Okay, I just have to call somebody in the room. Brenna. Correct. It is paired. And then would you say it's matched pair or repeated measure? Well, ready? I would say this. It's the same person. So you're being paired with yourself. Ready? The scuba diver removes their fin. A maker scuba diver. Each diver flips a coin to determine if they wear the new fin on the left foot, the old fin on the right foot, or the other way around. Okay? So it's the person's repeating it. Does that make sense? Like it's the same person. They're getting one of each fin. So it says two measures the same variable. So it doesn't really matter. Like when I say, is it matched pair repeated measure? That's not a good question because it doesn't matter. It's still blocked. It means you would do a one sample test of differences. You would put new fin in list one, old fin in list two, or the other way around, and you would do the difference of the list and a test on that to see if zero is in the interval or the p-value is small. How about this one? That's an easy one. Yeah, why? How do you know it? The two samples are different sizes. If they're different sizes, it has to be two sample. Yes? The hard parts are, is it matched when the sample size are the same? If the sample size are different, it has to be two samples. If they're the same, it could be one or the other. So the fact that the sample size are the same doesn't mean it's a matched pair. But it might be. I like this question. Can a wetsuit detect a terror shark attack? So you have a new wetsuit with color variations, and you just drop these people and ask them to see if they get attacked by sharks. We need volunteers for this experiment. Jake, you're volunteer for the experiment? You're going to put on a wetsuit and they'll drop you in the area of sharks during senior week? Okay. Let's make it at the end of senior week so you can still have some fun before it happens. They're not putting people in there. They're putting drums covered in the wetsuit. So what have you got? 16 2-hour time periods. 8 of them to the drum in the black wetsuit. The other 8 are assigned to the drum with a new suit. During each time period, the appropriate drum is submerged and the number of times the shark bites the drum. Okay, they're not matched up. But what happened? The sample size are the same. And that's what, they're both 8. It's got nothing to do with it. They didn't put the drum with the wetsuit, same drum. Black wetsuit, color wetsuit. Okay, it can be confusing. So here's what we got, which is how we started. And that was the last part. Determine when it's appropriate to use a pair test versus a two sample procedure. Oh, we did get a chat. A little late. Thank you. Late to the party there. Birthday girl. It's not your birthday, but your birthday's on the AP test. It is Hannah's birthday. So if you see Hannah Hoban, 11th grade class officer, tell her happy birthday. So that's what you're being asked. Here's the T-score. The numerator is how far you are from zero. The step divided by the square root of the sample size. And then here's the question, is it paired or two samples? So you're doing 3 problems. We're going to pause the video and send you to 87, 89, and 91. So for problem 87, they're asking you, do you have cause and effect? You cannot determine cause and effect from an observation. It has to be an experiment where the treatment's imposed, and this qualifies. So the null is there a difference between music and silence? Is that 0, or is it not 0? So you have random assignment of treatments. The sample size is large enough. We do a t-test of differences from the data they gave us, the stats, not the data meaning use lists. So the stats, they gave us summary statistics where that was the mean, and the step was 2.7. But we got what? We got a p-value of 0.0034. Like you look at the picture, you can't even see where it's shaded in because the p-value is so small. The t-statistic was greater than 3. We are in the tail. Reject the null. There is evidence that silence is more helpful in recalling words. Well, what do? We rejected the null. What kind of error could we have made? If you reject, the only type of error you could possibly make is type 1. That's what F2R is about. Because F2R says if you fail to reject, you might have made a type 2 error. We didn't F2R. We rejected. It's the only type of error we could possibly have made is a type 1 error. And then, ready? We rejected the null. And the p-value, if you double the p-value, because if we, well, you don't need to double because it's a two-tailed test. The p-value is less than 1%. So if we do a confidence interval of 99%, we would not anticipate finding 0. Well, we can't find 0. We did something wrong. So here's the interval. It goes from positive to positive. How did we know that? Because this is a 99% confidence interval. So there's 1% outside the interval. But the p-value was less than 1%. That's why we rejected it. And if we rejected it, then 0 would not be in our interval. Okay? So if you're at home, you are dismissed to do the exit ticket. We will see you in the building, hopefully on Monday. Okay? See, they give you different things. The p-value says the probability of getting what we got are more extreme by chance alone. The interval is telling you you're 99% confident that the true proportion's in the interval. And the interval is saying essentially 2/10 to 2 9/10. The student will recall between 2/10 and 2 9/10 of 20 words in silence more than while listening to music. That their recall goes up by between 2/10, I don't think I worded that very well, 2/10 and 2 9/10. And then, ready? To test the wear of 2 tire brands, each of 50 cars of the same make and model gets brand A or brand B tires. Now, what's happening? It's a leading question because they're telling, oh, it's the same make and model. So that makes me think it's, matched pair. There's no evidence that it's matched. Factory workers works without music and another month with music. And the month is randomly assigned. It's the same person. It's repeated measures. And then, how do young adults look back on high school romance? They interviewed a random sample of 40 couples. 40 couples is a matched pair. The husband and wife. Okay? You want to see how much the men and women differ on this measure. So they have numbered 1 to 40 are the couples. Couple 1, here was the difference in their score. Couple 2, couple 3. So we do a 1 sample test of the differences. Okay? So that's it for chapter 10.